this TE line, you will see this is a tangent line to the circle at point A. Tangent is the line that touches the circle at one point, and that is the point A. Okay. For now, and angle ACO is 35. A to C to O, that angle is 35, and angle BCO is 40. B to C to O is 40. Find angle AOC. AOC. Okay, so we have to find AOC. A to O to C. So the middle is this one here, the pink one. We have to find the pink angle. Okay, you know that OA and OC are the radii of a circle, so they both are equal in length. If they are equal in length, then you focus on the AOC triangle. If they are equal in length, then their angles made with the base will also be equal. So this angle is also gonna be 35, right? Because the both angle will be same now for an isosceles triangle. Okay. Now you know, if you look at the triangle AOC, that is an isosceles triangle where you know the two angles as 35, 35. How do you find the third one? So you add 35 plus 35, that gives you 70. And you know the total sum of the triangle is 180. So to get the third angle, we will subtract 70 from 180, which will give us 110. So angle at O is 110. Okay. So AOC is 110. That was for 1 mark. Angle ABC, A to B to C. So if you notice, go for A to B to C. So this angle, they're looking for this angle here at B. How do we find the angle at B? How do we find the angle at B? You know that, okay, we have a rule. If we have a circle, angle at the center, angle made by the points at the center is double the angle made by the same points at the circumference. This is the orange one is the angle at circumference. This angle is half the angle at the center. Okay. So if you notice, the point A and C, they are making an angle at the center as 110, and they are also A and C making an angle at the circumference, which is B. So we know that angle at the center is always double the angle here. So angle at B will be the half of the 110. Okay. So the half of 110 is 55. So angle at B is 55, right? Okay. Angle at B is 55. Now part C, angle DAC. We have to find DAC angle. Let's see, where is DAC? D to A to C, right? We have to find D to A to C. Okay, there is another theorem we will use. The tangent always makes an angle of 90 with the radius. OA is a radius, so it will make an angle of 90 degree with the tangent. Okay, so you know the total angle is 90, and you want to find out the black one, so you just do 90 minus 35. Okay, that will be 5, and 8 minus 3 is 5. Okay, that will be 55. So DAC, D to A to C is 55. So here you go. Now angle OAB, O to A to B. Let's see, where is OAB? O to A to B, right? Okay, O to A to B. So this is the angle. We have to now find the blue one. Okay, we know that if you will focus on the triangle ACB, you know that ACB, let me highlight it. Okay, A to C, ACB triangle, yeah. Focus on this blue triangle. We know the other two angles. So this total angle here, the red one, 40 plus 35 will be 75. Okay, and for this total angle, we know the half of it, which is 35, and the other side is b. Okay, so we can just write this angle, the pink one here. So we will now make it, I'm gonna erase it. Yeah, so this 35 plus this x is unknown, plus 75 this side, plus 55. Okay, they all add up to 180, right? Okay, so what is 35 plus 75 plus 55? 70, 30, 100, 110, 110 and 110 and 55 will be 165. Okay, so x plus 165 is equal to 180. Move 165 to the other side and minus it, you will get the x, so that will be 15. So this x, a little x here, is 15, right? That's 15. So your AOAB angle is 15. Okay, so we are done. That was word 1, 2, 3, 4. 4 marks question for circle theorems. Question 11. You have the diagram y equals f of x and the point P. The coordinates of P are already mentioned as -2 and 11. And there is a parabola on the graph. The tangent from P, if we draw the tangent from the point P, tangent is a line that touches the graph at one point. The tangent from P touches the graph y equals f of x at the point AB. Okay, the value of a and b are integers. By drawing this tangent, find the values of a and b. Okay, so I'll just zoom it out. Yeah, and then I'll draw the tangent from the point P. Okay, I'll draw the tangent from the point P, right? I'm just gonna go, no, I'm gonna use this line. Okay, yeah, we have to draw the tangent from the point P. Tangent, let me tell you, is the point that touches at one point, that touches at only point on the graph. And yes, you can see this is the tangent, and if you will, let me just show you the point. This is the point where the tangent is touching at one point. Yeah, alright, so we have to find the coordinates of this point. Okay, you can find the x coordinate as 1. Okay, and the y coordinate. How do you get the y coordinate? As you know, this is 5, so that represents 1, 2, 3, 4 and then 5. Okay, 2 blocks represent 1 unit, so 1 and 2 are the coordinates of this point. Okay, where the tangent is drawn. I have done it on the, I'm just trying to get the line straight. Yeah, okay, so this is the tangent line from the point touches the circle at 1 and 2, right? So the coordinates of that point where the tangent touches the graph is 1. A is 1 and B is 2. Okay, this is the point A and B. That's the point A and B. The A value is 1, B is 2. Now find the equation of the tangent. You have to find the equation of the tangent. Okay, so you know that to find the equation of a tangent, which is a straight line, we have this equation, y equals mx plus c. We should know the gradient and we should know the y-intercept, m and c. All we need to get is m and c. Okay, we know the c already. As you can see, I'll again use that point, because this isn't looking like a tangent here. Okay, I have this line here, blue one as a tangent, and I don't know why I'm unable to draw the line with the help of this ruler. P coordinates, I forgot what was that. Okay, so if you will look at this, this blue line, this is the tangent and we have to find its equation. You know that you need to get y equals mx plus c. You need to get the M and C. You can clearly find the C. C is the y-intercept and y-intercept is 5. Okay, so C is 5. And how do we get the M? We know that if you know the 2 points on the line, you can use the formula y2 minus y1 over x2 minus x1 for the gradient. Okay, and we have those points. This P point lies on the tangent line, so the coordinates of P are where are the coordinates of P? Yeah, negative 2 and 11. Okay, so the coordinates of P are negative 2 and 11. Negative 2 and 11. Okay, so this P point and this AB point lies on the tangent line. So we know one of the point is negative 2 and 11 and the other point is 1 and 2. Okay, we can use both of these points to find the gradient of that line. So y2 minus y1. Here you can take your x1 and y1 as the first point and x2 and y2 as the other point. Okay, so now you do y2 minus y1, so 2 minus 11 over x2 1 minus x1, which is minus 2, right? So 2 minus 11 is minus 9 and 1 minus minus 2 will be 3. So minus 9 over 3 will be minus 3. So you have the M as minus 3 and C. So the gradient for this line, this tangent line, is minus 3 and the y-intercept is 5. C is 5. Okay, so we will now go here. The gradient of that line is the gradient of that line is minus 3 and C is 5. Okay, so now we know that y is equals to mx plus c is the standard form of a straight line. So you replace m with minus 3 x plus c, which is 5. So y is equals to minus 3x plus 5 is the equation of the tangent. Okay, that was the question 11. Now question number 12. The time spent on the internet by each of 120 adults is recorded for 1 day. Okay, so here this cumulative frequency graph is given, which shows the information that how much time is spent by each of 120 adults. Okay, so there are total 120 adults which are plotted against the y-axis and the time in hours is plotted against the x-axis. Use the cumulative frequency diagram to find an estimate of the interquartile range. What is interquartile range? Interquartile range is basically upper quartile minus lower quartile. Okay, what is upper quartile? Upper quartile is the 75th percentile of the total cumulative frequency. Okay, that is the 75th percentile, and lower quartile is the 25th percentile. Okay, which we say is Q3 and lower quartile is Q1, right? So what is the 75th percent of the total cumulative frequency? So 50% of 120 is 60. Okay, and 25% is the half of 60 will be 30. So 60 plus 30 is 90. Okay, so that's 90. 75th or 75th percent, we have to find 75th percent of 120. 75% means 75 over 100. You know, you will get 100 for percentage of means times of 120. So this 0 0 cancels out and then it is 12 and then 10. 75 divided by 10 will be 7.5. Okay, and then times, because it's 1 0, so you will move the point 1 unit backward. That gives you 7.5 times by 12. So you can just multiply it and you will get the answer. 2 times 5 is 10, 2 times 7 is 14, plus 1 is 15. Put the 0, 1 times 5 is 5, 1 times 7 is 7. 0 and 5 plus 5 is 10, 7, 8, 9. Okay, now you have a point, you have one decimal, one figure. Now you have one digit after the point, So you will put the 1 point from the right, so that is 90.0, which is 90. Okay, so that's how you got the 90. This is 80 and 90, 1 2 3 4 5. This point is 90. Okay, so we get the upper quartile. We'll draw the line. We'll draw the line from here. This lines are too bad here. Okay, I know this is gonna be, if I'll join it from here, this is the point. Okay, at the end I mashed it up. Okay, so that's 1 2 3 4 5, that's the 5. So this point is 5.2, 5.4, 5.6. okay, that point is 5.6. so the upper quartile is 5.6. 5.6 minus the lower quartile. Lower quartile is the 25% of cumulative frequency. As you know, the 50% is 60. 50% of 120 will be obviously the half of 120 now, which is 60, and then 25 is the half of 50, so half of 60 will be 30. So this is 20, or you can do it this way, like 25% of 120, you will still get the 30. So 25 divided by 100 times 120. Okay, just do that, solve it, you will get 30. Okay, and this is 20. 1 2 3 4 5, that's 30 here. So if I join the line, I get 4.2. okay, this is 4.2, so lower quartile is 4.2. so 5.6 minus 4.2 will be 5 minus 1.4. so the interquartile range, which is upper quartile minus lower quartile, is 1.4 here. Okay, 1.4 hours is the interquartile range for the above data. Now 70% of the adults, we know there are total 120 adults, spend less than k hours on the internet. Use the cumulative frequency diagram to find an estimate of the value of k. Okay, so we have to find the 70%. As you know, the 50% of 120 is 60. Then what will be the 30%? Yeah, 20%. I mean 25% you checked was 30. Okay, and if you think it is hard, what you can do, you can just find out 70% of 120, which will be 70 divided by 100 times 120. This 10 goes away from the top with the top, and this 10 with this 0. So it's division 1 whole no value. 7 times 12 is 84. Okay, so that 84 cumulative frequency. If that's the 90, if you have the 90 there, yeah, okay, if you have, okay, if that's the 90, that's 80, 82, 84 is this line. Let me do that with green. That's 84. You're having a difference of 2 here. Okay, that's 8.2, 82, and that's 84. Oh, so now we go down this line and we get 5.6. okay, and let me just check it. I'm just having trouble drawing these lines. So 84, now we have to go down 84. So that's 82, 84. 84 is this line, and I'm gonna join. Okay, you can do good with the ruler obviously, but okay, this point here, so that's 5.2, 5.4. okay, so they spend 70% spend 5.4 hours, so k value is 5.4 hours. Okay, k value is 5.4 here. Use this cumulative frequency diagram to find an estimate for the value of k, which is 5.4. okay, so that one, this was the question number 12. Okay, question number 13. Question 13 says that a solid shows solid A. The diagram shows solid A, that's solid A, and solid B, that's the solid B. They say that solid A is made from a hemisphere, you know, the half of the sphere, which is this portion, and the cone. The above one is the cone with the radius 6 centimeter. Okay, the cone has a radius of 6 centimeter. That's ultimately is the radius for the hemisphere also, the sphere. Okay, the cone has a sloping edge 10 centimeter. Okay, so it has a slant height which is 10 centimeter for the cone. Okay, and we know the the radius as well. Solid B is a cylinder. It's a cylinder shape, and radius is 4 and the height is h. Height h is unknown and the radius for the cylinder is 4. Okay, what do we have to find out? The total surface area of solid A is equal to the total surface area of the solid B. Okay, surface area, solid A surface area. Okay, surface area of solid A is equals to surface area of solid B, right? Surface area of solid A, solid A is the surface area of the half hemisphere plus the surface area of the cone. Okay, so let me just write it here. Surface area for the solid A is the surface area of hemisphere, half hemisphere, plus surface area of cone. Okay, so let's find the surface area of half of the hemisphere. So half times the surface area of hemisphere. What is the surface area of a hemisphere? You can check it in the formula booklet. That's gonna be 4 pi r square. Okay, so surface area of half of the hemisphere, which is 4 times pi times r square, plus the surface area of the cone. What is the surface area for a cone? That is gonna be 2 pi rl. Okay, surface area of cone is gonna be 2 pi rl, but let's just confirm it once quickly from the formula booklet we have above. To avoid the confusion, this is the formula booklet you have, and if you will see the surface area, where is the surface area for the cone? It's not here. Yeah, curved surface area of the cone. Okay, which is with radius r and sloping edge l is pi rl. Okay, that's pi rl, not 2 pi rl, that's pi rl. Okay, so we'll just go back to the question number 13 and now write the surface area of the cone, which is pi rl, right? Pi rl. Okay, now we're gonna keep it equal to the surface area of the solid B. Solid B is the cylinder. Okay, so let me tell you what is the curved surface area for this cylinder. The curved surface area is 2 pi rl. Okay, that is the curved surface area. But if you notice, you have two circles as well on the top and at the bottom. So we will, the area for one circle is pi r square and the opposite side is same, so it will be plus 2 pi r square. Okay, the area for the two circles plus the curved surface area for the cylinder, so 2 pi rl plus 2 pi r square, okay, is equal to 2 pi rl plus 2 pi r square, right? Now we're just gonna substitute the values in it. Half times 4 is just 2, okay, and then pi r. What is the radius for the hemisphere? Hemisphere and the cone share the same radius with 6, so that's gonna be 6 here, square plus pi r. Radius again is 6, length l is the slant height, so the slant height for this cone is 10, okay, so that is gonna be 10, yeah, times 10. So this is the surface area for the solid A, where you share the half of the hemisphere surface area and the surface area for the cone. This is the surface area for cone, that's the surface area for hemisphere. We add them both to the surface area for the solid B, which is 2 pi r times L. 2 pi r L, h, I mean 2 pi r h. 2 pi r times h, the height. Okay, so radius for the cylinder is 4 centimeter and the height is unknown, right? So that's 4, r is 4, height is unknown, h, plus 2 pi r is again 4 squared. Okay, now we are going to simplify this thing and we will get the h. So 6 squared is 36, so 2 pi times 36 plus 6 times 10 is 60 pi is equals to 2 times 4 is 8 pi h plus 4 square is 16, 2 pi 16. 2 times 36 is 72 pi plus 60 pi is equals to 8 pi h plus 2 times 10 is 20 pi. Okay, 72 pi plus 60 pi will be 132 pi is equals to, from both of them you can take the pi common, so you will have 8h plus 20 inside it. Okay, so pi cancelled out from both sides, it's just 132 is equals to 8h plus 20. Move 20 to the other side, 132 minus 20 will be 112 is equals to 8h. Divide both of them by 8. So the height will be, what is 118? 112 divided by 8. So 8 times 1 is 8. 8 times 1 is 8. 3 Garys goes over there, that's 32. 8 times 4 is 32. Okay, so the height is 14 centimeter. So you see, by keeping the surface area of the solid A equals to the surface area for the solid B, according to the given condition, we were able to find the height of the cylinder. Okay, so the height is 14 centimeter. Okay, that was 5 marks question. So you just have to work according to the requirement of the question to get the unknown thing. Now work out the height of the solid A. So we have to find out the height of the solid A. So if I draw the line, this is the height for the solid A. From the top you draw a straight line till the center. Okay, this is the height for the cone, and then you get this green length. This green is the, obviously from the center to any point on the hemisphere is the radius, which is 6. We know this green length is 6, right? Now the problem is we have to find this height. Okay, h. So you can look at this right angle triangle inside a cone. This angle is 90 degree, and the two sides, and you want to find out the third side. You can apply the Pythagoras theorem here. So Pythagoras says that the square of hypotenuse Pythagoras says that the square of hypotenuse is equals to the square of adjacent plus the square of opposite side. Okay, so hypotenuse is given to be 10. As you can see, this length is 10 here, right? So 10 square is equals to h square plus opposite square, which is 6. Yeah, so 10 square is equals to 6 square plus h square, and 10 square is 100 is equals to 6 square is 36 plus h square. So 100 minus 36 is equals to h square. 100 minus 36 will be 9 minus 3 is 64. Okay, h square, you take the square root, and which will be 8. It's plus minus 8, but the height is always positive, so we will take positive 8 as the height. Okay, so we know the height is positive 8. Okay, and that the total height of the solid A is 8 plus 6, which will be 8 plus 6 is the total height, right? Which will give you 14 centimeter. Okay, so yeah, you notice that the height for this solid A is 14 and the height for the cylinder A is also 14.